Hello there, welcome to CXC Math TV. In this video, we're going to be talking about trigonometric ratios. Really nice. We're going to learn trig ratios. Absolutely beautiful. Now, the first thing you're going to wonder is, what is trigonometric ratio? What is trigonometric ratio? So here the term ratio. So trigonometric ratios are defined as the values of trigonometric functions based on the value of the ratio of the sides of the right angle triangle. So we're going to really be looking at the ratio of the sides of the right angle triangle. Now the ratios of the sides of a right angle triangle is what we're going to be looking at when the angle is acute. So consider this right angle triangle right here. Alright, looking at this diagram right here, we see that this is triangle PQR. Alright, and we know that the opposite is the side that is across from the angle theta. We know that the adjacent is the side directly below the angle, and we know the hypotenuse is the longest side. Alright, so in this case we can see that the opposite therefore is PQ with a length of A. The adjacent is QR with a length of B, and the hypotenuse is PR with a length of C. Now, the trigonometric ratios are as follows. On your calculator, you're going to see a sine, cos, and a tan. On the calculator, you're going to see sine, cos, and tan. So take a minute, just pause for a minute. We're going to bring up our calculator, and we're going to show you sine, cos, and tan on the calculator. Alright, now that you've seen our calculator and you saw sine, cos, and tan, the trig ratios are saying that the sine of theta is the opposite divided by the hypotenuse. The cosine of theta is going to be the adjacent divided by the hypotenuse, and the tan of theta is the opposite divided by the adjacent. Nice. So just bear in mind, remember our opposite is A, and our hypotenuse is C, and our adjacent is B. Alright, so in this case, from our diagram, we're seeing that the sine of theta is A over C, the cos of theta is B over C, and the tan of theta, which is the opposite A over the adjacent B, is going to be A over B. Alright, so remember, sine theta, opposite A over hypotenuse C, cos of theta, adjacent B over hypotenuse C, tan theta, opposite A over adjacent B. Alright, cool. Now if you don't believe it, you can always try an experiment. So to prove trigonometric ratio, try this experiment. I want you to construct 4 right angle triangles in your notebook. Then measure the length of each side of the triangle. Label each side as A, B, and C, and try to make C be the hypotenuse, the longest side. Now measure one angle from the triangle apart from the right angle. Alright? And then we want you to write down this table right here. Complete this table. So for the first triangle, you want to write down which side is the opposite to the angle, the adjacent to the angle, and the hypotenuse to the angle. And then you need to divide the opposite by the adjacent. Then you need to divide the opposite by the hypotenuse. Then you need to divide the adjacent by the hypotenuse. And then I want you to put in the sine of theta, the cos of theta, and the tan of theta into your calculator, and just observe what you notice. Observe. So for this experiment, we're going to prove it using the geometer sketchpad. Alright, lovely. So we're going to prove this experiment using the geometer sketchpad. As promised, we're now going to verify the trigonometric ratios by constructing a triangle. So we're just going to create a triangle right here. So let's just make up a triangle. And the triangle we're constructing is a right angle triangle. All right, so here's our triangle. And we're just going to label the endpoints A, B, and C. All right, now that we have constructed a triangle and labeled the endpoints, let's measure the length of A to B. And we'll measure the length of A to B. We just click on measure distance. That's 5 centimeters. So 1, 2, 3, 4, 5. Cool. Now we can choose any one of these 2 angles that we want to use. The angle that we're going to focus on is the angle at C.
So let's measure angle ACB. Angle ACB. When we measure that angle, we're getting 45 degrees. So let's place it right here. Angle ACB is 45 degrees. Now, since this angle right here is 45 degrees, then AB is going to be the opposite. AB is going to be the opposite because it is across from the angle. So now let's measure BC. So when we measure BC, BC is the adjacent. So we measure BC, let us measure it. BC is also 5 centimeters. All right, nice. So now let's measure AC. We measure AC and that's 7 centimeters. Now remember AB, this side is our opposite, BC is our adjacent, AC is our hypotenuse. AC is our hypotenuse. All right, lovely. So now, if we're to write it down, we have that our opposite is 5 centimeters, the adjacent is 5 centimeters, the hypotenuse is 7 centimeters. Now, the opposite over the adjacent would be 5 over 5, and that is 1. That's equal to 1. Now, A over C is going to be 5 divided by 7. And B divided by C is also going to be 5 divided by 7. B is the adjacent divided by the hypotenuse. Now let's look in our table now. We're going to look in our table and see if these values are working out to be true. All right. We're going to look at the sine of theta, the cos of theta, and the tan of theta. And remember, theta is the angle that we chose. And the angle, remember, theta is the angle that is inside the triangle that's being under consideration. The angle inside the triangle is 45 degrees. So now we're going to take out our calculator. All right, so now we take out our calculator. Now we're going to evaluate the sine of theta. That's the sine of 45 degrees. The sine of 45 is root 2 over 2. That is 0.7. This is giving us 0.71. So the sine of theta is giving us 0.71. And observe, what is 5 over 7? Remember, we said sine theta is going to be opposite over hypotenuse. Opposite over hypotenuse is A over C. Now let's check and see if opposite over hypotenuse is still 0.71. So 5 over 7. That's also 0.71. You see that? Opposite over hypotenuse is also 0.71. Nice. Let's see now the cos of 45 degrees. So now the cos of 45 degrees, cosine 45, 0.71 as well. And 5 over 7, we already know that's 0.71. Nice. So we can see that the trig ratios are proven to be true so far. Good. The tan of theta, I know the theta is missing right here. We just need to open up the border a little bit. But the tan of theta is then, tan theta is opposite over adjacent. Opposite over adjacent, we got that to be 1. Now we're going to find out if the tan of theta is also giving us 1. So we need to look at the tan of 45 degrees. Is that 1? Absolutely. So look at that. So we're going to color code it. So what we're saying then is the opposite over the adjacent. If we put that in red, this is also going to be equal to the tan of theta. Nice. If we look at A over C, which we say this should be the sine of theta. So let's put that in a different color. Let's use blue. Those are equal. And if you work out B over C, we can see that that is also the cos of theta. Nice. All right. So that verifies it. So you can construct other triangles, and see if the trig ratios are going to work out to be true. All right. You should construct your other triangles and test to see if these trig ratios will be true.
Alright, so now you're probably wondering, so why should I know about this trig ratio, right? Why should we know trig ratio? Well, trig ratios in real life are used to measure the heights of towers. So some of those tall towers that you see builded, and we may need to do some calculations regarding measurements of towers. So that's one there. We use trig ratios to determine the distance of the shore from the sea. We use trig ratios to find the distance between two celestial bodies. We use trig ratios to determine the power output of solar cell panels at different inclination. And that is when we're going to talk about angle of elevation and angle of depression. And we also use trig ratios when we're talking about representing different physical quantities such as mechanical waves and electromagnetic waves. So you do a little bit more of that in physics. So that's the need of trigonometric ratios. Beautiful. That's in real life. So now that we know the trig ratios, let's look at some question. Alright, so we're given this right angle triangle right here. Triangle ABC. And it says find the missing side BC. So looking at it, we are given the hypotenuse. The hypotenuse AB is 15 centimeters. And the angle given is 25 degrees. So we need to find BC. But BC is opposite to the angle. So since BC is opposite to the angle, what is the length BC? BC is therefore the opposite. So since BC is opposite to the angle, BC is the opposite. Now when you have the opposite to find, and we're given the hypotenuse, which trig ratio is that? Sine. So we use that the sine of 25 degrees is BC over 15. And so if you cross multiply and make BC the subject, BC is 5. If you cross multiply and make BC the subject, BC is 15 times the sine of 25, and that is 6.34 centimeters. So the length of BC is 6.34 centimeter. Easy like that. It is just like that. Now what if you were asked to find the missing length AC? Now to find the missing length AC, we'd have been given the hypotenuse. Now since we're given the hypotenuse, what do we know? We know the hypotenuse and we know the angle is 25. Now to find the adjacent and the hypotenuse, that relates to which one of the formulas? Cosine. Beautiful. So we're just going to say the cosine of 25 is equal to AC divided by the hypotenuse of 15. And so AC, if you make the length AC the subject, we get AC is 15 times the cosine of 25. And so AC works out to be 13.59 centimeters. Easy. Beautiful. Nice. Now, I want you to observe something right here. Look at the triangle ABC again. The opposite square plus the adjacent square would be 6.34 square plus 13.59 square. That works out to be 225 when we put that in our calculator. But 225 is 15 square. And in the previous video, remember, opposite square plus adjacent square is hypotenuse square. So we can clearly see that, of course, if the trig ratio is true, then Pythagoras theorem is also going to be true for that same triangle. Now let's try another question. It says, given the right angle triangle below, find the missing side CB. So go ahead, pause this video and attempt it. As we pause and attempt, right, we would have been seeing that, well, the angle is 40 degrees and the side opposite to the angle CA, right, that side opposite to the angle is CA, and that is 10 meters. So we can say, okay, now we need to find BC. So BC is going to be, now BC is which side? BC is the side that is adjacent to the angle. Okay, so we have opposite and we need to find adjacent. Which formula has both the opposite and adjacent in it? That is tan. So the tan of 40 degrees is going to be 10 divided by BC because it's opposite over adjacent. So we make BC the subject, and so BC is 10 divided by the tan of 40 degrees. and you put that into your calculator and you get 11.91 meters. Beautiful. And so we can finally tell them BC is 11.91 meters. What if you were given a worded question and then asked to use trigonometric ratios? What would you do? What would you do? Alright, so let's look at a real life question now. This question here says two islands A and C are 3 kilometers apart. A third island B is located due south of A and is due west of C. From island B, the angle between A and C is 33 degrees. Calculate how far island B is from island A and from island C. So pause the video and attempt. So as you pause and attempt, let's break down what is told, right? Let's break down what was told. We are given that A and C are 3 kilometers apart. We don't know where A is from C. We just know that the distance between them is 3 kilometers. Now we do know a third island B is located south of A. South means directly below. And so from A to B, we can put on a point and put on another point and draw a line connecting them. And that is going to be AB, because from A to B, that's how we represent B being south of A. And then it is said that B is west of C. So we know then that C is to the right of B, right? C is going to be to the right of B, because C is to the right of B, because we can say that C is east of B, or we can say B is west of C. So we know that C is to the right of B. So we draw a line from B to C. And then now we connect it, draw the line from A to C. Now let's put on the information given. AC is 3 kilometers. And then the question says that the angle between A and C is 33 degrees. So put 33 degrees on our diagram. Now we can use our trigonometric ratios to solve. So now AB would be what? AB is the side opposite to the angle, and so we use sine. So the sine of 33 is going to be AB over the hypotenuse, and the hypotenuse is the distance between A to C. So we transpose, and AB is therefore 3 times the sine of 33 degrees, which is 1.63, and we put kilometers. Now to find BC, BC is what? The adjacent. Since BC is the adjacent, it's going to be the cosine. Cosine deals with adjacent. So the cosine of 33 degrees is equal to the adjacent CB over the hypotenuse 3, and then we transpose. And so CB is equal to 3 times the cos of 33 degrees, which is 2.52 kilometers. Nice. Or just to close rather, we just need to remember some information. Anytime you're given a right angle triangle, the side A, in this case, which is opposite to the angle theta, we call that the opposite. Alright? And the side that is beneath or below or beside the angle, we call that the adjacent, that is B. And the longest side of the triangle, which is the hypotenuse, we call that C. And the trig ratios deduce that the sine of theta is the opposite over the hypotenuse, the cos of theta is the adjacent over the hypotenuse, and the tan of theta is the opposite over the adjacent. Beautiful. Alright? So from this diagram, the sine of theta is A over C, the cos of theta is B over C, the tan of theta is A over B. Once you know trigonometric ratios, you're absolutely fine and you're doing good so far for trigonometry. Alright, so just to leave you with 2 more worded questions, here you go. You can attempt those 2 questions. After you attempt those 2 questions, leave your answers in the comment section. And so that's it from CXC Math TV. So stay tuned for more. Alright, and see you next time. Make sure you have a blessed day.